So let's look at this exercise here. The one-period securities market model consists of two securities and a bank account. A bank account is assumed to be risk-free. The bank account pays interest of 10% per year and is risk-free. The price of each security today is 100. There are three possible scenarios for the prices of the risky securities in 1 year. In the real world, it's not three, it's thousands, but if you can write them out, you should be able to calculate things. So scenario 1, security X pays 220 and security Y pays 0. So scenario 2, security X pays 55 and security Y pays 0. So in scenario 3, security X pays 0 and security Y pays 250. The price of each of those is 100. Calculate the state price vector for the securities market model if one exists. If there is no state price vector, explain why. So this is what we have. You have the following system of equations implied by the existing price structure. And I want you to go over this carefully with me, please. What I'm saying here is this. The bank account, if you put 100 in it, will pay you 110 no matter what happens at time 1. That's our first security in this market, the bank account. The second is security X, the third is security Y. Okay, a payment of 1 in state 1 and 0 otherwise is called the arrow the brew security E1, and the price of it is psi 1. So if your bank account pays 110 in state 1, then the value of that payment today is 110 times psi 1. The bank account also pays 110 in state 2, and the value of that payment today is 110 times psi 2. And if the bank account pays 110 in state 3, then the value of that today is 110 times psi 3. But we know that the bank account, we assumed we put 100 in it. So that has to be equal to 100. For the second security, the payment in state 1 is 220, and it's worth today 220 times psi 1. The payment in scenario 2 or state 2 is 55, and it's worth today 55 times psi 2. The payment in scenario 3 is 0, and it's worth today 0 times psi 3. But we are told that the second security price is equal to 100, so this must be equal to 100. And for the third security, the payment, security Y, the payment in state 1 or scenario 1 is 0, and the price of that today is 0 times psi 1. The payment in scenario 2 or state 2 is 0, and the price today of that is 0 times psi 2. And finally, the payment in state 3, scenario 3, is 250, and the price of that today is 200 psi 3, and we are told that the price of that is 100. What you see is that once we write out all the information about possible prices of these securities, we conclude that that we have three equations with three unknowns, and the unknowns are the prices of the arrow de Bruce securities. Well, we can solve this, and the solution is unique. The solution will be unique if the matrix of this system of equations is non-zero. And you can very quickly check that it's not, because you write out the matrix of 110, 110, 110, 220, 55, 0, 0, 0, 250. And this matrix can be made diagonal if you switch the second and third row, and then the calculation of the determinant becomes very simple. It's non-zero. So there is a unique solution. And the solution is psi1, psi2, psi3 is equal to 24 over 25, 4 over 55, and 2 over 5. Now recall that the risk neutral probabilities are equal to 1 plus the interest rate times, so Qj is 1 plus the interest rate times psi j. So in this case, if you multiply all three by 1.10, what you get is 24 over 50, 4 over 50, and 22 over 50. So notice that the sum of the three entries in psi1, psi2, psi3 is not equal to 1, because these are not probabilities. These are prices of Arrow-Debreu securities. But the sum of all entries in Q1, Q2, Q3, well, it's 24 plus 4, so 28 plus 22, so it's 50. 50 divided by 50 is 1. And so these are probabilities. And knowing this, we can calculate the price of any security in this market. For example, a security that pays 0 in the first state of the world, 1 in the second state, and 2 in the third state, has the price of 24 over 50, the probability of the first state, times discounted value of 0 paid in that state, discounted by 10%, plus 4 over 50, the probability of being in the second state, times 1 over 1 plus 10%, so discounted at 10%, plus 22 over 50, the probability of being in the third state, multiplied by a discounted value of 2 and discounted at 10%. And then that's equal to 0.8727. And I just give you a simple example of a two-dimensional market model and a simple calculation. You are given a securities market described by prices at time 0 of 1.1 and payouts at time 1 of 1.1, 1.20, 0.90. Calculate the arbitrage-free price of a European put on the second asset expiring at the end of the period with a strike or exercise price of 110. So we set the system of equations for the prices of Arrow-Debreu securities. 1 plus psi1 plus 1 plus psi2 is equal to 1, and 1.2 psi1 plus 0.9 psi2 is 1. And we solve it. Psi1 is 1/3, psi2 is 2/3. Note also that in this case, the risk-free interest rate is actually 0, and these two add up to 1 because they are equal to Q1, Q2. The put described in this problem has cash flows of 0 and 0.20. And we can write this as 0 times 1.0 plus 0.20 times 0.1. And its price will be 0 times the price of 1.0, which is called psi1, and 0.20 times the price of 0.1, which is psi2. So it'll be 0 times 1/3 plus 0.2 times 2/3. And that's 0.4 over 3 or 2/15. This is exactly the standard calculation in the two-dimensional market. Now here is another two-dimensional market. You are given a securities market described by S of 0 is 1.1, S of 1 is 1.1, 150.90. Find the state price vector. So again, we form this system of equations. Psi1 plus psi2 is 1, 1.5 psi1 plus 0.90 psi2 is 1. And we solve it. Psi1 is 1/6, psi2 is 1/6. And the risk neutral probabilities are equal to them because this setup that you see here, what you see here, is actually telling you that the risk-free interest rate is 0. How come? Because the risk-free security is the one that has the same payoff no matter what happens, right? So the first security pays 1 in the first state and 1 in the second state. It pays the same no matter what happens. If it pays the same no matter what happens, then it's risk-free. That the payoff of investing 1 in it at time 1 will be 1 plus the interest rate. If 1 plus the interest rate is equal to 1, then the interest rate is 0. So in this market, the interest rate is 0. And we had 2 such markets already in the 2 problems. In this next problem, we have 1.1, 1.10, 1.10, 1.20, 0.90. Now the risk-free interest rate is 10%. To find the state price vector, we write 1.1 psi1 plus 1.1 psi2 is 1, and 1.2 psi1 plus 0.9 psi2 is 1. I'm sorry, and we get a solution, and we also get the solution is 20 over 33 and 10 over 33, and the risk control probabilities are 2/3 and 1/3. Okay, so that's following the same setup. And here is actually, there is a formula for the Q1 and Q2. These are the formulas for Q1 and Q2 in the two-dimensional markets that I'm giving you here.